Hello and welcome back. Today we're going to be talking about simplifying radical expressions again. Our objective today is to be able to simplify radical expressions. Remember, a radical expression is an expression that contains a square root. The radicand is the expression underneath the radical sign. In order to make sure we are getting these problems correct, we have to make sure our answers are in simplest radical form. In order for something to be in simplest radical form, it has to follow these three rules. The first rule is no radical has perfect squares other than 1. We have no radicals that contain fractions. We have no radicals appearing in the denominator of a fraction. Next up, we have our list of perfect squares. To get your perfect squares, all you have to do is multiply that square root by itself, and you'll get the perfect square. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And the pattern continues down the list. Now, we do have more perfect squares, but the main ones that we really care about is up to 256 should be plenty for us. We really won't go much beyond that probably. Today we're going to be talking about the quotient property of square roots. We talked about the product property of square roots last time, so today we're going to be focusing on the quotient property of square roots. What that allows you to do is it says if you have the square root of a over b, you can rewrite that as the square root of a over the square root of b. Now, let's go ahead and look at our first example. The first thing I always like to do on any example is simplify the fraction if I can. So 5 over 9, that cannot be simplified, so I'm simply going to rewrite it as square root of 5 over square root of 9. Now, I like to think of this as two separate problems. The first thing I have is the square root of 5. The square root of 5 cannot be broken down at all, so it just simply stays the square root of 5. Because there is no perfect square that breaks it down. Now the square root of 9, that actually is a perfect square, so we can break that down. The square root of 9 is 3. So we can write 3 on the bottom. And if you look at our three rules for something to be in simplest form, this actually follows them. So we have arrived at our final answer, which is square root of 5 over 3. Our next example. Once again, I like to simplify anything that I can. So 20 over 49, that cannot be simplified at all. However, if I have x to the third over x, that can be reduced to x squared up on top there. So I'm going to go ahead and rewrite this as 20x squared up top over square root of 49. Now, once again, if we treat this as two separate examples, we can go ahead and do that. So we have square root of 20. And we have square root of x squared. The biggest perfect square that breaks down 20 is 4. And the biggest perfect square, or then 4 times 5, gives us that 20. The square root of 4 is 2. Good there. And x squared is a perfect square, so we can actually break that down, and it is simply x. Remember, to take the square root of a variable with an exponent, all you have to do is cut it in half. So on the outside up top, we have 2x times the square root of 5. On the bottom of our fraction, we have the square root of 49, which if you look, 49 is actually a perfect square, so we can break that down. And the square root of 49 is 7. So on the bottom of our fraction, we have that simplified all the way down to 7. And that actually is our final answer. Next up, we have to talk about rationalizing the denominator. Rationalizing the denominator is a method used to eliminate radicals from a denominator, because sometimes we will have a radical in the bottom of our fraction, and there won't be anything that we can do about it. So 10 over 3 cannot be simplified at all, so we simply rewrite it as the square root of 10 over the square root of 3. If I break down square root of 10, that cannot be simplified at all. And the square root of 3 can also not be simplified at all. We are not allowed to have a radical in the bottom of our fraction, which in this case we do. We have a square root of 3. So what you have to do, and this is kind of our tricky part for today, is whatever is in the bottom of your radical, of your fraction, you simply multiply both the bottom and the top by that exact thing. And once you do that, square root of 10 times square root of 3 is the square root of 30. And the square root of 3 times the square root of 3 is the square root of 9, which we know the square root of 9 is 3. Another way to think about it is these two things kind of undo each other. So root 3 times root 3 is 3. Next up, we have our next problem here. And like I said, we always want to simplify our fraction first if we can. So 2 over 6 can be simplified to 1/3. So I have the square root of 1 over the square root of 3. The square root of 1 is pretty easy to do. That is 1. So I get 1 up top. The square root of 3 cannot be simplified at all. So we just simply leave it as the square root of 3. Once again, we have a square root on the bottom of our fraction, and we cannot have that. So we have to multiply both the top and the bottom by whatever is underneath that radical. It's called rationalizing the denominator. 1 times the square root of 3 is going to be the square root of 3 over 3. So for this one, we can actually start, we can multiply everything together first. So we have 7 times 5 is 35, and 2 times 3 is root 6. Now we go ahead and we check to see if there's anything that can simplify this fraction, which there is not. 35 over 6 cannot be simplified at all. So we simply try and break down square root of 35, which there is no perfect squares that break that down. So we simply just have square root of 35, and also we have square root of 6. Nothing breaks that down, so there's nothing we can do to this fraction. So what we have to do is we have to multiply both the top and the bottom by root 6. If we do that, 35 times 6 gives us a root 210. And root 6 times root 6 is 6. We do the same thing on this problem here, so let's go ahead and 2 times 3 is 6. 3 times 4 is 12. However, these fractions can be broken down, so 6 divided by 12, that is going to be 1/2. So we have square root of 1 over square root of 2. Let's break both those down as separate problems. So square root of 1 is 1. Up top, we can write 1. Square root of 2, can't do anything with that, so we just leave it as square root of 2. Now, once again, we have a radical on the bottom, so we cannot have that. So we say, multiply both the top and the bottom by root 2. And we get square root of 2 over 2. 2 more problems to go here. Let's go ahead and look at this one. So we have 27 over 5. That cannot be simplified at all. And we have an x to the 5th and we have a y. So there's nothing we can do there. So we leave this as 27 x to the 5th over the square root of 5y. So let's break down the 27x to the 5th. So we have root 27. We have root x to the 5th. The biggest perfect square that breaks down 27 is going to be 9. So we have 9 and 3. Square root of 9 is 3. Over here we have an odd number for our exponent, so we have to take one away from that. Square root of x to the 4th is x squared. So on the top part of our fraction, we wind up getting 3x squared root 3x. On the bottom, the square root of 5 and the square root of y, neither of those can be broken down at all, so we are just simply left with square root of 5y. All we have to do to finish this off is multiply both the top and the bottom now by 5y. Once again, this is called rationalizing the denominator. And when we do that, we still have 3x squared on the outside, but on the inside, 3 times 5 is going to give us 15, and then we have xy underneath our radical as well. On the bottom, remember the 5y's basically cancel that radical out, so we are just left with 5y. One more problem to go, and then we are all done here. So same exact principle as last time. So we have root 18 m to the 7th. We have root 7n. Nothing can be simplified, so there's nothing that we can do there. So up top, we have root 18 and root m to the 7th. The biggest perfect square that breaks down 18 is 9. And then we have a root 2. The square root of 9 is 3. M to the 7th is an odd number, so we have to make it m to the 6th and m. So we got m to the 3rd there. So up top, we are going to have 3 m to the 3rd, 2m underneath our radical. On the bottom, that's 7n. The square root of 7, there's nothing we can do there. The square root of n, there's nothing we can do there. So we simply have to just leave it as the square root of 7n. We rationalize our denominator. And our final answer is going to be 3m to the 3rd square root. 2 times 7 is 14. M n. Root 7n times root 7n is going to be just 7n. That is our final answer, and we are all done for today. I will see you guys next time.